Hello, my name is Ashwarya Pillai. In this video on reduction potentials, you are going to learn how to determine whether a reaction is spontaneous or non-spontaneous using its cell potential and Gibbs free energy. In order to determine whether a reaction is spontaneous or non-spontaneous, you must either know the value of the cell potential or the change in Gibbs free energy. Gibbs free energy is kind of like money in the bank. Certain activities you do increase that money, like working at a job, while other activities decrease it, like going bowling. Similarly, some reactions lead to a positive change in free energy, meaning that you end up with more energy than you began with, while others lead to a negative change, meaning that you end up with less energy than you began with. These types of reactions are spontaneous because they give up energy in the process. Reactions that take in energy and therefore end up with more energy than they began with are considered non-spontaneous. Non-spontaneous reactions occur in electrolytic cells, like those in your phone or computer, and require a battery, which contains galvanic or spontaneous cells, to drive the reaction forward. So, if the change in Gibbs free energy is less than zero, the process is spontaneous and occurs in a galvanic cell, like a battery. And if the change in Gibbs free energy is greater than zero, it's considered non-spontaneous, and it occurs in an electrolytic cell, like the ones in your phone or computer. Cell potentials have the opposite pattern. So if a cell potential is positive, it denotes a spontaneous reaction, while a negative cell potential denotes a non-spontaneous reaction. Remember that cell potentials indicate the energy per unit charge that is available from the redox reactions. So positive cell potentials mean that usable energy is generated, while negative cell potentials mean that energy is consumed. So let's apply this to a few questions. The first question asks you to predict the signs of the change in Gibbs free energy and the cell potential for a spontaneous reaction. Since you know that a negative change in Gibbs free energy and positive cell potential indicate a spontaneous reaction, the change in Gibbs must be less than zero and the cell potential greater than zero. Similarly, for a non-spontaneous reaction, the change in Gibbs free energy will be greater than zero and the cell potential will be less than zero. The second question asks you to determine whether a reaction is spontaneous, based on the change in Gibbs free energy or the cell potential. In A, since the cell potential is positive, the accompanying reaction must be spontaneous. This is further supported by the negative change in Gibbs free energy. In contrast, since the cell potential in B is negative, the corresponding reaction must be non-spontaneous. Finally, since the change in Gibbs free energy is positive in C, it also indicates a non-spontaneous reaction.